In about 7 billion years, everything that is our Sun, a star that has burned for over 10 billion years, will be reduced to a slowly cooling ember the size of the Earth, quietly fading in the darkness forever. When a star of moderate mass, up to about 8 times the Sun's mass, exhausts its nuclear fuel, it sheds its outer layers as a planetary nebula, leaving behind a hot, dense core called a white dwarf. A typical white dwarf contains roughly the mass of Sun compressed into a volume comparable to Earth. The density is extraordinary. A tablespoon of white dwarf material weighs about 5 tons. White dwarfs no longer fuse elements in their core. They are technically dead stars. Their support against gravity comes not from nuclear burning but from electron degeneracy pressure, a quantum mechanical phenomena where electrons resist being squeezed into the same state. The Pauli exclusion principle, the same quantum rule that governs how electrons arrange themselves in atoms, is what holds a white dwarf up. In 1930, a 19-year-old Indian physicist named Subramaniam Chandrasekhar, on a ship from India to England, calculated that electron degeneracy pressure has a limit. Above about 1.4 times the mass of the Sun, the quantum pressure cannot prevent further collapse. This is the Chandrasekhar limit. Exceed it and a white dwarf becomes either a neutron star or, in the explosive case, a type 1a supernova. Chandrasekhar won the Nobel Prize for this discovery 53 years later in 1983. Here is something beautiful. As a white dwarf cools over billions of years, the carbon and oxygen inside it can crystallize. Literally, the core of the dead star turns into a crystal structure similar to diamond. Astronomers have actually detected this crystallization process in white dwarfs. In a few billion years, the Sun's remnant will be a diamond roughly the size of Earth, slowly cooling in interstellar space. Eventually, over timescales so vast, a white dwarf cools to the point where it no longer emits significant light or heat. At that point, it becomes a theoretical object called a black dwarf. But the universe is not old enough yet for any black dwarfs to exist. Every black dwarf ever predicted is still a glowing white dwarf.